Welcome, friends, to Science Talk. This is your host and resident oceanographer, Jim Assa. Okay, a little article that appeared in EOS, which is kind of like a headline news publication by the AGU. And what do we see here? Warming oceans are making the climate crisis significantly worse. Yeah, think? Because again, everyone focuses on the atmosphere, not realizing that the oceans have absorbed 93% of greenhouse gas energy emissions for the past 50 years. And that is going to bite us in the ass. This is why, when everyone says, we can get to zero net emissions, this, that, and the other thing, it's like it's not going to mean diddly squat because we have all this 226 zetajoules of energy in the ocean waiting to diffuse out to the atmosphere. Even if just 1/4 of that did, we're in deep trouble. Humans have locked in at least 20 feet of sea level rise. Can we still fix it? How? Okay, so greenhouse gases that are heating the atmosphere contribute to ocean warming and lead to sea level rise. Now around the world, average sea levels are expected to rise by 20 to 30 feet. So that's something in the order about like 7 to 10 meters or something like that. Sea level rise. Well, you got thermal expansion. You're melting all the ice, so you got the freshwater input that will increase sea levels, and then that surface water, especially if it moves into mid latitude, will warm up, further expanding the sea level rise, etc. So the climate emergency is bigger than many experts, elected officials, and activists realize. Well, excuse me, but not to do a shameless plug here, but I will. I've been saying that the emergency is bigger. There are many, many others who saying that the emergency is bigger. It's just that we're not getting the platform. We're not getting our message is not being carried by, so we say, mainstream media and other means and venues. But there are those of us out there who have been, trying to ring the clarion bell about what the hell is coming down the pipe here. So please do not include me in that list. Humanity's greenhouse gas emissions have overheated the Earth's atmosphere, unleashing punishing heat waves, hurricanes, other extreme weather events. That much is widely understood. Yeah, and that's just with 7% of greenhouse gas energy for the last 50 years. The larger problem is that the overheated atmosphere has in turn overheated the oceans. I beg to differ the way they worded that. It's not that the air has warmed the oceans, that the oceans have absorbed directly the energy from the sun. Now, if you want to say they work in conjunction because the atmosphere ocean interface, okay, but the oceans have been also directly absorbing the sun energy. Let's put it that way. So basically what they're saying is that we're going to have a catastrophic amount of future sea level rise. Now, I've discussed with you before that if all of Greenland was to melt, we probably would see a sea level rise of about 7 to 10 meters or so, which is what that 20 to 30 feet is all about. And then you toss in Antarctica, and that's a low end, by the way, for Greenland. You toss in Antarctica, and we could see sea level rise if all of Antarctica were to melt. We're talking a total of 57 to 72 meters of sea level rise worldwide. That might take a millennia or so for that to happen, but it could very well be that we could be locking this in because as the heat diffuses from the oceans to the atmosphere, further warming the atmosphere, further accelerating the melt of Greenland and Antarctica and alpine glaciers, yeah, you could have, by the end of a millennia or so, you could have a 57 to 72 meter rise in sea level. That's what a lot of the models are indicating. So the key question is how soon the sea level rise will happen and whether humans can cool the atmosphere and oceans quickly enough to prevent part of this. Cooling the oceans, that means you have to drastically remove, because think again, specific heat of water, you have to drastically remove that heat energy. And where are you going to put it? Think about how air conditioners work. They do what? They take the heat that, let's say you're trying to cool down your bedroom, right? So you got an AC in there. It takes the heat that's in the bedroom and does what? It dumps it outside. That's what air conditioners do. They just move heat. So you're trying to cool down the water, where are you going to move that heat to? Going to cool down the atmosphere, where are you going to move that heat to? If seas rise 20 feet over the next 2,000 years, well, it might be more like 210 feet over the next, say, 1,000 years, maybe. Our children and descendants may find ways to adapt, but if the seas rise 20 feet or more over the next 100, 200 years, which is the current trajectory, well, that ain't so good. That's not looking so good. It'll be 2 feet of sea level rise by 2040, 3 feet by 2050, etc. And by the way, a 2 foot sea level rise will be catastrophic for a lot of places, a lot of cities that are, like Shanghai, New York, Miami, Boston, the Netherlands. It'll be bad. 2 to 3 feet will transform human societies over the world. South Florida residents will lose access to fresh water because we are having seawater or brine infiltration into the groundwater. So the water is no longer potable. Sewage treatment plants will fail. Large areas will persistently flood. And don't forget, it's not just coastal areas that will flood, but if you have like a major river drainage system like the Mississippi, the Amazon, you're going to have the sea level. You're going to have that water flowing inland and flooding basically the deltas and the drainage system. Think of during the Jurassic era when you had the huge inland sea basically bisecting the North American continent. New Mexico used to be beachfront property. So you're gonna have the water not just increasing at the coastal area, but it's going to move inland, and it's going to move inland significantly. And of course, the higher the rise in sea levels, the further inland this push will happen. And then, of course, that's bringing salt water, so that's going to infiltrate, the water table, the groundwater, so that you're going to get brine infiltration. It's going to ruin crops. People won't be able to drink that water. It's going to be very, very bad. Okay? Now, you could develop crops that are tolerant of brine. That's a possibility, but you still have the issue of you have brine in the water. You need to remove that salt before humans can drink that water. Sewage treatment plants will fail because now you got all this rising water and all the fecal material will kind of float away. Miami Beach, other barrier islands will largely be abandoned. China, India, Egypt, other countries with major river deltas, 2 to 3 feet of sea level rise will force the evacuation of tens of millions of people and the loss of vast agricultural lands. So attempting to limit sea level rise must become an urgent priority. And apparently that's what Joe Biden's going to be talking about, whatever. And again, they talk about the Paris Climate Accord, limiting temperatures to 1.5 to C may not be sufficient. The same, we're at 1.2 now. We're actually, a lot of the studies I'm seeing, a lot of the measurements I'm seeing is that we're already past 1.5. The 1.2 is because the IPCC keeps moving the goalposts. It used to be based on 1750 standard. Now it's like, oh, no. Let's look at 1850 to 1910 levels. Compare it to that. So they keep moving the goalposts, which is, that's just disingenuous. So what's the solution? Stop putting more heat-trapping gases into the atmosphere. Duh. And we must extract much of what we already put up there. Since the Industrial Revolution 250 years ago, the amount of CO2 in the atmosphere has increased dramatically. To minimize future sea level rise, we need to lower that amount from today's 417 ppm towards the 280 ppms that prevailed before industrialization. 417? More like 421, and that's just looking at CO2. If you factor in nitrous oxide and methane, then the CO2e equivalent ppm starts approaching 600 parts per million. I've seen other calculations taking it up to 700. But even going with the conservative 600 ppm of CO2 equivalent, that is a huge increase, and that is very dramatic, and we're seeing the results of that. So halting heat trapping emissions requires moving economy off fossil fuel to renewable, ending deforestation. Very good point there, because the Amazon is now a carbon source, no longer a sink. We got the permafrost dying. How are you going to stop that? Shifting to climate-friendly agriculture, planting soil-building forests, etc. Cooling the oceans will be harder. You think? This requires pulling massive amounts of CO2 from both the atmosphere and the ocean and storing it where it cannot leak. And where might that be? There are prototypes of carbon-negative technologies like incorporating pulverized basaltic lava into fertilizers can lead to CO2 removal. Okay, I don't know enough about that to make a comment, but let's just say when it comes to geoengineering schemes, I am, shall we say, quite skeptical. I discussed, for example, why iron's seeding the oceans didn't work. Oh, I love this statement. Our dilemma is rooted in basic physics. Yeah, that's right. You can't argue with physics. Physics is physics. Once CO2 is emitted, it remains in the atmosphere for millennia, trapping heat and warming the planet like a blanket. Right? Cloud cover. What's insufficiently appreciated is that most of this warming, yeah, right, there it is, that 93%, that 93% has transferred to the ocean, significantly warmed the upper 2,000 feet. Actually, we can see that warming down to 2,000 meters. This is accelerating polar ice melt and global sea level rise, and will continue to do so for centuries. How are you going to cool down the oceans? You really can't, because it's physics. Okay? Let's face it, we pushed ourselves over the edge, over the tipping points. In 1900, global sea levels were rising 0.6 millimeters a year. May not sound like much, but what's the surface area of the planet? How much is covered by oceans? After the 1930s, ocean warming and water expansion kicked in. The rate of sea level rise doubled and doubled again, reaching 3.1 millimeters a year by 1990. Since then, as ever-warming oceans have driven polar ice melt, the rate of sea level rise has increased much more. Now they're rising at 6 millimeters a year, which is, let's be consistent here, folks. 2 inches is, 5 centimeters. Okay? So if you want to keep the same unit, 6 millimeters a year, 50 millimeters a decade. Let's keep it consistent. And this pace is expected to continue to increase. Okay? I did that video on the ocean heat content where I talked about how the sea level rise itself is an exponentiating function, that there is an acceleration to that. And this is being reflected in these statements here. 5 centimeters a decade may seem trifle, 50 millimeters, but this is just the beginning of the acceleration. NOAA has projected that in 2017, global mean sea level rise could rise 5 to 8.2 feet by 2100. Okay, so that's basically about 2 to not quite 3 meters by 2100. 4 years later, it's clear that 8 feet is a moderate projection. 2021. Regional influences, subsistence, subsidence, changing ocean currents, and redistribution of Earth's mass as ice melts will cause some local sea level rise to be 20 to 70 higher percent, 20 to 70% higher than global. A sea level rise of almost 3 meters would be catastrophic. Absent extensive and very expensive adaptation measures, it would put much of New York, Washington, D.C., got a bad thing for Washington, D.C., Shanghai and Bangkok, Lagos, Alexandria, and other coastal cities underwater. It would submerge South Florida. Yay! And then building seawalls won't help in South Florida. The land rests on porous limestone. Yeah. So rising seas will, let's get under it all. Even levee protected Netherlands and New Orleans would be in trouble. Based on current trends, if the seas increase only by almost 2 meters by 2100, that will be considered to be fortuitous. Put that in quotes. The reason is the computer models used by NOAA and others do not reflect what we know about how seas have risen in the past. These models assume that sea level rise unfolds gradually, but the geological record shows that, in fact, it occurs in rapid pulses. Warmer temperatures following the previous ice age caused disintegration of one polar ice sector after another, causing seas to rise in pulses of basically 1 to 10 meters per century. Today, accelerating ice melt in Greenland and Antarctica almost certainly the beginning of a new pulse of rapid sea level rise. It is urgent that humanity transition to renewable energy, stop burning fossil fuels, and develop and deploy technologies to get the CO2 from the skies and seas. Good luck with that. And then you got to get realistic about adapting to the sea level rise. Well, you know what? If you can start flooding out these cities, you know what that means? You're going to have huge amount of climate refugees. So, and then you have lost that land area. So you have the same number of people, but you now have less land to put them on. So where are you going to put them? Where are you going to, and if you're starting affecting the food, the agriculture, how are you going to feed them? There are serious problems that are presented with this. Without such measures, there will come a point sooner than many people realize. Well, I'm one of those that realizes that because I've been saying this. When civilization as we know it will greatly weaken or outright collapse. I've been saying this. I did a story like over a year ago or longer where, excuse me, I discussed how a think tank out of Australia, based on their analyses, say that by 2050 human civilization will collapse. So this, removing heat from the oceans, good luck with that. And you just can't argue with physics. We have already set in motion so many things that we're basically guaranteeing our own, shall we say, removal as a species. But this is what's coming down. The sea level rise, is going to affect cities, flood cities. It's going to affect groundwater, the water table. It's going to affect crop, potable water, because you're going to have the brine infiltration. Water will not be drinkable. Crops will fail. And then you're going to create climate refugees. Sea level rises are going to keep increasing. It's not and then you couple that with the changes in precipitations, droughts, fires, so on and so forth. The future is grim and bleak, to be quite blunt. So I just wanted to bring this little story here. It appeared originally in The Nation, but these are things you've heard me discuss before. And now we're starting to see more and more other people saying, hey, there's something serious going on here. Well, maybe if you listen to the oceanographers more so, we were telling you this stuff here. If you listened to us earlier, could maybe, and earlier I mean like several decades earlier, maybe you could have put mitigative techniques and procedures in place. My own assessment, looking at the data and the models and the projections, it's already too late. So, there it is. Thank you for your time. We'll talk soon. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.